This is question 2 from paper 2-3 from the June 2020 exams from Cambridge International. Up the top right of the screen you'll find a card that will bring you to a playlist of all my other solutions from this paper. And in the description below you'll find a link to an image of this question so you can try it out before looking at my solution. In this question they ask us the exact coordinate of the stationary point of this curve. Now we don't know what this curve looks like and we don't need to do this solution, but if you're studying, if you're not in an exam right now, you can put it into a graphing calculator, especially one online, and I'll pop that up onto the screen now. And as you can see, here is the shape of the curve. And we can see where the stationary point is. It's around about x equals 2 and the y coordinate is a little unclear. Now that's just to give you an idea of what this question looks like. Like I said, we don't actually need that. We hear stationary point, we should be thinking dy dx. We need to differentiate this. And this question has some difficulty to it. That's why they've asked it. Because it's not easy to differentiate this, we're going to need to use the product rule. Now the product rule means just breaking it into two parts, each part having an x, each part needing to be differentiated separately. So we have a formula for this. This is u and v, and I'll just write here. The formula would be du dx. So we differentiate the first bit and we leave the second bit alone. Then we differentiate the second bit and we leave the first bit alone. It's given to us in the exam, it'll be in our formulas. So let's try do that. Let's differentiate the first bit, and that's 5x differentiates to 5. And we leave the second bit alone, e to the power of a half x. Plus, we differentiate the second bit. Okay, this is a bit difficult, but again, it's in our formulas how to differentiate exponentials. But we don't, well, all we need to remember about this is if y equals ex, we differentiate dy dx is equal to ex. That's one of the ways we actually define the exponential, or we can define it. Don't quote me on that. I'll have to check on that one. So that's how we differentiate ex. E to the half x, we just use the chain rule in the middle of it. We pretend the half's not there. We pretend this whole thing, a half x, is just x. So the answer is just e to the half x. No matter what's there, it looks the same. But we're not allowed to do that. We're not quite allowed to do that. We have to accept that the half is there. So to deal with that, we use the chain rule. We differentiate what we've just ignored, the half x. And if we differentiate a half x, the derivative is just a half. We multiply. That's the chain rule. So sorry, that's dv dx, and then we multiply that by u left alone. Okay, hopefully that was clear. Write some comments below. Let me know if that wasn't, if you need any extra help, or if I just should stop saying it that way. Okay, so this is dy dx. Now remember, we're asked for a stationary point. That means, well, I won't write it on that line. That means dy dx equals 0. That's how we find the stationary point. So let's try and play around with this a bit more. Let's see, there's 5 in this, and plus there's 5 over 2, 5 times a half, x, multiply, and both of these multiply by the same thing, e to the half x. And this equals 0. I've just factorized it. I'm missing an x here, am I? Oh, this should be x instead of e. I've factorized this question now. So whenever something equals 0, it's really helpful to factorize. Because that means there's two possible answers. 5 plus 5 over 2x equals 0, or e to the half x equals 0. Now this one's impossible. I'll throw up another picture on the screen now. It's a graph of e to half x. And as you can see, it never quite equals 0. It gets close as we go further and further left. It'll get very close, but it'll never quite equal 0. So that means this is impossible. Another way to see that is to try and solve it. Natural log of both sides, natural log of the left gives us a half x, and natural log of 0. Try put that in a calculator. The calculator will give out to you. It'll say impossible, it'll say, you might say infinite or something, error. Anyway, we can't do it. There's no answer to this one. Because this line will never equal 0, as the picture shows. That leaves us this one, which hopefully is where the answer is. So this will tell us that 5 over 2x is equal minus 5. Just bring this over. And multiply by 2, we get minus 10. Divide by 5, we get minus 2. x is equal minus 2. So many students leave that as their answer, x equal minus 2. It's not. They didn't ask us what x was. They asked us find the exact coordinate of the stationary point. They want minus 2 something. They want something to be written here. So how do we do that? Well, we know what y equals. That's all we're missing, y. So let's just write what y equals. Y is equal to 5 minus 2. Not x, that's minus 2 now. Minus 2e to the power of a half times minus 2. Let's clean this up. We get minus 10. Half multiplied by 2 is 1, or minus 1 in this case. Minus 1, that's equal to, we'll leave it like that if you want, or minus 10 divided by e. Now, another mistake students made is they put this into a calculator, and I'm not sure what they get, like 3 point something. But no, they didn't ask us for a calculator's answer. They didn't ask us for 3 significant figures. They asked us for the exact answer. Yeah, find the exact coordinates. The exact coordinates are this. In maths, and this is one thing lots of students have trouble with, you need to get used to using letters as an answer. And minus 10 divided by e is a perfect answer. It's an exact answer instead of decimals. Again, with pi and square roots, sometimes it's better to leave your answer looking like that than a calculator. If the question asks for 3 significant figures, give them it. But otherwise, we should always leave them the exact answer. Okay, so that's the coordinate. And does that look roughly right from our picture? I think it does. Minus 2. I think I said 2 earlier. And the e would be in the minus world of minus about 3 or 4. All right, thanks for watching. Like I said in the middle, if you have any questions, let me know. And I'll see you next time. Have a good one.